We now finish the proof that matrix multiplication is well defined on M2R. Remember, this is where we left off. Now, since we know that ordinary multiplication is well defined, we are going to start building up various pairs of these entries that are equal. So, since multiplication is well defined on R, it follows that. And we're going to get 8 pairs of numbers here that are equal. Now, we want the AE to equal SW. Let's see, we get that because A equals S and E equals W. Now, we want BG to equal TY. And we get that because B equals T and G equals Y. Similarly, we can see that we get the other 6 pairs of numbers equal that we want. We get AF equals SX. We get BH equals TZ. We get CE equals UW. We get BG equals VY. We get CF equals UX. And we get DH equals VZ. Each because then on the left equals on the left, and on the right equals on the right, and ordinary multiplication is well defined. So now let's use the fact that addition is well defined on R. Since addition is well defined on R, it follows that. And now let's add the first and the second pair, the third and the fourth pair, the fifth and the sixth pair, the seventh and the eighth pair. Addition is well defined, remember, means that we can add equals to equals and still get equals. So let's do AE plus BG equals SW plus TY. AF plus BH equals SX plus TZ. CE plus DG equals UW plus VY. And CF plus DH equals UX plus DZ. Now, let's put these into a matrix. This looks like a pair of corresponding entries. This in the middle looks like a pair of corresponding entries. This looks like a pair of corresponding entries. This looks like a pair of corresponding entries. So by the definition of matrix equality, it follows that. And you see now we're going to get a pair of matrices that are equal to each other. If I take the entries on the left of each equal sign AE plus BG, AF plus BH, CE plus DG, CF plus DH, that's going to equal. Now if I take the things on the right of each, SW plus TY, SX plus TZ, UW plus VY, UX plus VZ. Now, we had already worked out on scrap paper, this matrix equation here is the same as this equation that is a product of matrices. So by the definition of matrix multiplication, it follows that and now we'll put this in as a product of matrices. A, B, C, D matrix times the matrix E, F, G, H equals matrix STUV times matrix WXYZ. But these were the matrices A, B, C, D, A, B, Y, and Z to begin with. So therefore, we make that matrix A times matrix B equals matrix Y times matrix Z. And that ends the proof. Notice that the most important piece of this proof was talking through how I worked it backwards. I could get up to here by following my nose, but if you just read from the top down after this, you would wonder, how the heck did I see how to do this? How the heck did I see each of the steps that followed this? And the answer was from the first video, working backwards on scrap paper from A times B equals Y times Z, where I wanted to end up, to various expressions of pairs of numbers that were equal. Okay, we have now proven that matrix multiplication is well defined. What that means is if you take any two matrices and multiply them, there is only one possible correct answer for their product. More to follow.